quantized. There are discrete energy differences. Okay, now that's not too enlightening there, but let's go back. Let's go back to this very crude picture of our atom, where this is the first major level, the second, the third, the fourth, and so forth. Okay, this is what they found, that if we took an atom and we put some energy into it, maybe some heat energy into it, that, let's make it as simple as possible. We have one electron in our system, so we must be talking about hydrogen. And it's sitting right here. This would be its electron configuration, 1s1. We refer to that as being the ground state. Now that's kind of a strange word, ground, like you're standing on the ground. It just means the usual lowest energy state. So if we put some heat energy in here, what happens, we can excite that electron. That's the term they use. You're exciting electrons. And it absorbs energy. It's absorbing some of that heat energy. But it gets up here in this so-called excited state. And of course, you could add enough heat energy, it would get clear to the third or to the fourth or whatever. But if it just goes from here to here, it's absorbed some energy, but it's not stable up there in the excited state. So what happens, just immediately, it drops back down. When it drops back down, it releases that energy, but not in the form of heat. What happens is that you heat it up, it accepts the heat, absorbs the heat, but it drops back down, it gives off light energy instead of heat energy. Okay, when it gives off that light energy, it's a particular color. Okay, now that means if it's a particular color to your eye and your brain, then it must be a particular wavelength. And if it's a particular wavelength, it must be a particular energy. Okay, so they go, how could that be? Why is it always the same? If you take copper, you see a bluish-green color. A particular energy is coming back at you. So they came up with this idea. There is a discrete difference between these two. It's not a continuum. And so we say, the atom is quantized because the energy levels are at discrete energy differences from each other. Now let's think everyday life. School. I'm guessing most of you came up the stairs here. You didn't take the elevator. Maybe a couple of you took the elevator, but I bet the majority of you took the stairs. When you come up the stairs, okay, the architect built those stairs, a particular design, and they're about this far apart, and so when you're walking up the stairs, you take one step at a time, or it's almost 10 o'clock, and you love your chemistry class, so you're in a big hurry. You're going to run up the stairs and you go 2 at a time. Or if you have really long legs, you might go 3 at a time. Okay, you're not going to take a step and a half, or you're going to fall on your face. You're not going to take, a half a step, you're going to fall on your face. We could say that the staircase is quantized because each step is a discrete energy difference apart. Okay, now what, on the other hand, what if the architect had built a ramp, like over at Reliance Stadium, where they use ramps a lot? Okay, if there was a ramp down there at the end of the hall, then you could take whatever size step you wanted. You could crawl if you wanted. You could take little steps, big steps, whatever's comfortable for you. So we would say a ramp is unquantized. How about a ladder? It's quantized. You got to take discrete steps. You step on this rung, then you step on that rung. You can't take a rung and a half, or you might fall off the ladder. And then one of my smart kids yesterday, he says, what if you get to the top and then you slide down? You know, instead of step by step. Well, yeah, if you're, so I made him switch over to the firehouse, you know, the fireman's pole that they slide down. Quantized or unquantized? Unquantized, because you just hang on and slide, rather than using a quantized staircase. So that's where the term came from. And we can see that. Let me just do something here real quick, if I can. I've got several different elements.
Are you saying?
Yeah.
Are you saying that it has to be a set distance apart?
Yeah,
Is
they
that
must
basically
be.
the defining?
Yeah, that's
So
what
if it's not set, then it would be unquantized.
Yeah, exactly. Okay, now Emily, can I get you to run the lights for me?